Hello, class, and welcome to Chapter 4. Chapter 4 is all about loops, 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 loops. So we'll start, I guess, with the definition. What is a loop? A loop is a control structure with code in it that will execute during the validity of a certain condition or until the validity of a certain condition, meaning that, we can as long as the condition is true, we can keep executing code in the body of the loop, or until a condition is true, we can keep executing code in the body of the loop. So we'll dive right in with a while loop, which is the first structure that the text discusses. While loop has a syntax while. In these parentheses, you might have guessed it. Yeah, there's a Boolean expression that goes in there. And then you have your code block, right? You have your, whatever, do stuff. So we could say, there we go. I got it. Remember, we seed our random value. So then, there we go, random percent. We'll want a value from 0 to 9. And so we say while, here, int, rand int equals, while rand int is not 8, then we'll display it. How about that? Or here, we'll just do a space. All right. So here we have a Boolean condition. Rand int is not equal to 8. That's either true or false, right? So this is a good example. This is just this is a very artificial example, but hey, until rand int is 8, it'll keep going, it'll keep printing the value of rand int. Oh, yeah, by the way, I'll have to give it a new random value. This may execute rather quicker than the system clock resolution, and so we may see some repeated values. Let's see. Pen include range. Wait a sec. Am I losing my mind? Probably. Oh, yeah, that's it, time. Math. Give me a sec, I'm drawing a blank, sorry. It's been a while. Well, I just checked and it should be C time. I don't know why. I swear I put C time, maybe not. All right, yeah, I was losing my mind. Okay. All right, so what we do, we seed a random value with the current time. And then we say, hey, while we give it our initial value in this way, when we say while, it's going to be some value between 0 and 9 each time, right? Between 0 and 9. We say while, as long as it's not 8, just go ahead and print out the number. If it is, then we'll break out of the loop and we'll say, rand int value was 8. There we go. 1, 0, 4, 0, 7, and then bam, we hit an 8. Let's do this again. That was fun. 1, 5. Ooh, we got it in 4 tries. 4, 0. 1, 9, 9. Hey, it took a long time. 0, 6, 3, 2, 6, 3, 3, 7, 1, 3. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 before we hit 8. Whoa, we had a whole big string. 3, 4, 1, 3, 3, 2, 7, 1, 4, 4, 5, 6, 2, 7. Anyways, so you see what it is. While this condition is true, when it goes to not true. Oh, here, you know what? We'll take one of these executions. This is good learning. 10407. We'll go loop by loop. So we have initial value of 1, and we say, yeah, that's true. Random is not equal to 8, so we'll execute the code in the block. We display 1. We got 0 here, right? 1, 0, 4, 0, 7. We say, hey, it's not 8. Let's keep going. Then we got 4 here. Okay, we'll go up to the top, execute the code again if this is true, which it is, because 4 is not equal to 8. All right. Then we have a 0 resulting. Come to the top and say 0 is not equal to 8, so we'll execute the code. 7, right? And then we say, yep, random is not equal to 7. That's true. And then we got the 8. We came to the top, and we said, ooh, we cannot execute this code, this block of code, because random does in fact equal 8. So there you go. And that happened, and it just took a long time to happen here. Yeah, and each iteration is just an execution of this code block. The iteration will only, this is kind of like a Boolean gate, right? It won't allow you to proceed unless this is true. When it goes to false, then we break out of the loop and we transfer control to the line after the closing brace of the loop. You have to be careful. This may seem attractive to you if you want to do something until a condition is met. You better make darn sure that you meet that condition down here, or you are going to find yourself inside an infinite loop. Here, let's just, this is a silly contrived example. This would probably happen to you. If you code enough, you just get caught up in some silliness. Trust me. So I'll say. Ooh. All right, let's see. There we go. Some of you may have already found the problem. Cool, right? All right, let's quit. Oh, man. See what I did? I have two variables and I just used the wrong one here. This is an example of an infinite loop. Now, some of them that are automated you won't catch. It'll just kind of spin and spin and spin and spin in the loop, and you won't know why. You won't know where this happened. You'll have to kind of put some cout statements, do some debugging to find it. So that's an example of an infinite loop. If you use while true, hoping to catch some condition inside of here to make the loop break, which you can use the break statement to break out of the loop, as we'll see, then that's stylistically considered to be bad because it lends itself easily to infinite loops. Infinite loop, of course, is bad. We don't want to, unless we explicitly want to spend all of our time doing something, we generally don't want an infinite loop. Anything to execute, loop and loop and loop and loop and loop and loop. Otherwise, why would we have anything after before the construct? You see what I did? Enter value for I, -1 to quit. Let me go back here. So I corrected it. I put, I as the terminating condition. This is called a sentinel value. Hey, if you enter -1, I'll quit. While I is not equal to -1. As soon as I equals -1, this condition is false. Because I not being equal to -1 is false, because it is. Therefore, we exit the loop. Don't execute this code in it as soon as I equals -1, and then come out here. So now, let's try. Wait a sec. Oh, did I not? Oh, yeah, I must not have compiled. Sorry. There we go. Uh-oh. While. We do have an exit here. Why didn't... Losing my mind again. All right. Doesn't matter. I didn't read a value in, but who cares? Ci equal Cni. Oh, I'm doing it at the beginning here. Well, all right. Gosh, getting sloppy here. It's been a long day. Something's funny. Let me clean this up a bit. Sorry. Oh, all right. So when you look at, it's easy to gloss over stuff. Again, if you read your own code, you're kind of doomed to failure. It's why 4i stuff is good. I read holistically, as do, I'm sure, 99% of you. Some of you will pay attention to the details. The rest of you your mind will interpret and substitute what you thought you saw. Hang on, I don't like that message. There we go. All right. Now one, two, sorry. All right, let's do this cleanly. There we go. Okay, so now we'll have success. 1, 2, 3, and bam, out of the loop. I was equal to -1. That's a sentinel value. Now, do while is very similar to a while loop, except you see while can exclude you from even entering the gate here with this initial condition. So if I initially, right out of the gate, if I said, hey, I is -1, it never went into the loop. Because it looked at this and said, oh, I is equal to -1, we're not executing. If you know that your code needs to execute at least once, you can do what we call loop and a half, which is a do while loop. Do blop while blop. Do stuff while stuff is true, or while this is true. Let's give an example. If we know we want to execute something at least once, let's say we want the user, we want the user to, what's a good example of a do while? What lends itself to a do while? Let me go back to Zybooks. I'll get a contrived example otherwise, just a sec. You know what, maybe we can put our initial condition here. So let's see, do, yeah, we'll put our stuff inside the do loop. So that way we don't have to do, an outside and then an inside. Oops, I didn't mean this. Gosh. Sorry about that. There's kind of an example, so that we don't have to put, we don't have to repeat ourselves. Enter value for I, -1 to quit. Otherwise, we had to do it outside and then for each iteration inside. There you go. The only caveat here is that the value is displayed. If we're okay with that, then that's cool. So do while can be useful, again, particularly where you know that you want the loop to execute at least once. That is a flag that you want a do while loop. This is my favorite loop. 4. I do this in my sleep. I dream about this sometimes on accident. All right. For syntax. This loop will execute 10 times. So in a for loop, we have three pieces here. In the condition, we have the initial, we have the variable initializer. We have the exit condition, or the conditional, if you will, and then we have whatever assignments we want to make. So you see what this one does is it says, hey, for this integer I, it starts at 0. As long as it's less than 10, it's still valid. So it'll stop after loop 9, because once it increments each loop, you have something that happens. So here's your initializer, here's your condition, and then here's your your code that executes your incrementer, your code that executes with each iteration of the loop. So we start at 0, and then with each iteration of the loop, we add 1 to I. So we start at 0, then we go 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 on your hands, you get 10. Then when we come around to the I equals 10, it says, hey, the condition is no longer valid. I have to exit the loop. So this loop will execute 10 times. And we can see this to be true. There you go, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, we can even in C++, you can't in C. Well, you can, I think, in C11, so I don't know, something like that. But C14, I don't remember. But we can create and initialize our variable for the first time inside the loop. So we don't need a separate int I statement. I'm all about conciseness as long as it doesn't obscure, readability, as long as it doesn't, hamper readability. So there we go. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So first we have in I equals 0. Yes, it's less than 10. All right, we'll display it, and then we'll add 1 to it. Now we come back up, and we say, okay, now it's equal to 1. Yes, it's less than 10. We display 1. Hey, it's still less than 10, so we continue. I equals 2 now, because we added 1 to it. It's less than 10. We display 2. Add 1 to it, now it's 3. 3 is less than 10. Display 3. Add 1 to it, now it's 4. Still less than 10. Add 1 to it, it's 5. Less than 10. Add 1 to it, it's 6. Less than 10. Add 1 to it, 7, 8, 9. And then when I equals 10, we say, oh, I is not less than 10 anymore. We got to quit. We don't execute the inside of the loop. Then we transfer control to after the loop. There we go. There we go. Make it a little more readable. All right, that's a for loop, excuse me. Nested loop. All right. So, you can have two variables. If you want to iterate over a set of things, this is quite useful. You may think it's silly, but no. Let's just say we have two data sets. One has 10 elements, one has 5. We want to iterate over both of them. You know what, here. This is called a nested loop because it's nested inside the other, kind of like the Russian nesting dolls. Oh, see, there's a mistake right there. Logic mistake, not a syntax mistake. Ah, too much Java. There we go. So we can iterate over each element in our set. In this case, I just have a set of numbers, right? 0 to 4 for 0, and so on up to 9. But this way we can be sure to iterate over every combination of elements that way. And we can do this three-dimensionally too. We can say there we go. All the way up to 9, 4, and 2. Right? 10 minus 1, 5 minus 1, and 3 minus 1. So you get kind of all combinations of the elements. So that way you can iterate through sets, nested sets, whatever. So nested loops are very useful. You will use them if you do any programming. Break. Ah, yeah. So here you go. Break and continue. All right. So the temptation is probably to say, if you just want to be pragmatic, oh yeah, forget it, I'm just going to go ahead and go for it. While true, I don't know. Breaks out of the loop completely. You're done with the loop. Oh, val. Oh, yeah. Whoa, hey. Oh, you know what? Duh. Here we go. Oh, yeah. Oh, it's funny. I use negative 9999, but I see my prompt actually says 99999. But anyways, I knew what I meant. And so yeah, there's example of using a sentinel to break. That is the break keyword. It will break you out of a loop. Gets out of the loop completely. Now, let's say there we go. So what the continue does is it As soon as it hits the continue keyword, it transfers control to the top of the structure again. That's what continue does. It doesn't continue execution. It doesn't, start at the next line. It goes back to the next iteration up here. So let's watch this in action. 1, 2, 3, 4. Now if I enter a negative value, it should just kind of, yep, look at that. It doesn't echo it back. Oops, darn. It doesn't echo it back to me because I say, hey, if it's less than 0, continue, meaning skip this else. Or actually, you know what? I don't even need the else. That'll prove the point even better, actually. There we go. See, we don't get the -5 echoed. Sorry, it's over here on the left. But we don't get the -5 echoed back to us, nor do we negative anything. So that proves to you that as soon as we hit the continue keyword, we skip to the next iteration of the loop. We don't execute the code after it. So that's the continue keyword. These are both very useful structures for working inside loops. And scope. Watch this. All right, so I have an integer named val, right? I'm working with it in here. Inside the loop, I've also created an integer. You know what? Here, I'll increment I each time. Now, when I get out here, what I want to do is I'll say I'm out of the loop, and I want to display the value of I. How many times was I in the loop? Oh man, oops. There we go. Oh, why did I do that? Sorry. We'll just say inside the loop in I equals 0. Sorry, I wasn't thinking. I was not declared in this scope. Where does it point? It points to line 26, position 11. So let's go to line 26, position 11, right here. It says, what is I? Well, I's right here, dummy. What do you mean? Okay. Inside this scope, you see we have we have blocks, right? Inside the block is considered the scope specific to that block. If we create variables inside of that block in this scope, then once we leave this scope, this block, they will go out of existence. They will be out, what we call out of scope. So in I equals 0, I is only valid inside this block, between this curly brace and this curly brace. So when I try to reference it out here, it says, hey, I doesn't exist. I don't know about I. It's already gone, disappeared. So that's out of scope. Scope matches directly with blocks. Now, the converse is true. Obviously, I can, or the other way around, and I equals 0. Obviously, I can reference I here and it doesn't gripe at me. We've seen this already. Why is this? Well, this is because, see, I'm in my main. My main function scope starts here and ends here. This nested block here, what we call a nested block, inside this while loop, is definitely within scope of main. So there you go. So that's how you can think of scope. I hope all this made sense. These are, you can get these are building blocks. You can get as complicated as you want, but as long as we understand what they do and give you a simple example, you can synthesize this. You can use this to build much, much bigger things. This is a very important chapter here, a very important structure. Have any questions, let me know. Otherwise, I will see you at the next lecture. Thank you.